Hello everyone, so this is a video on an example on how to solve an application for lesson 6.3, and this application talk about sample means. So far we have found means, standard deviations, z-scores, probabilities for basically a population mean. So when we are finding all these probabilities, it's for an entire population, right? Now what happens when we are only choosing a group out of that population? So basically like a random sample, right? So let's say instead of working with like everyone from the Riverside County, we're only going to be working with the people from Riverside. So the random sample will be just like that population on Riverside instead of the entire Riverside County. However, um, we still have the information for the whole population proportion, right? So what do we do there? And basically these are sample means or sample distributions, and we're gonna have to change our standard deviation, which is gonna cause a change for the z-scores, right? In contrast to the lesson for 6.2, where we only had to find the z-score with the information given, right? Well, now there's gonna be a slight change. These are actually coming from the central limit theorem. So the central limit theorem, again, it's basically when we have a sample size of n that increases without limit. And then the shape of the distribution of the sample mean takes the replacement from a population with means and standard deviations that will approach a normal distribution. So we have a population n, right? And that population can be increasing. However, our sample, it's only working with a specific number of the population. In this case, that number n is a 50 movie. So in this problem, let me go ahead and read the problem first. It says, in a recent year, the average movie ticket cost is $7.89. In a random sample of 50 movie tickets from various areas, what is the probability that the mean cost exceeds $8, given that the population standard deviation is $1.39? So here our n value, which is the size of the sample, it's 50, right? So n equals 50. Again, we're working with a sample, right? A random sample, not the entire population or the entire number of movie tickets out there. They want us to find the probability when the mean cost exceeds $8, right? So that will be basically like our x value. And then we have that the population standard deviation. So this is population standard deviation equals $1.39, right? And then it says that the average movie ticket, so our mean equals $7.89, right? So again, we are trying to basically find the standard deviation just for the sample. When we are working, this is a standard deviation for the population. When we are working with a sample, we need to change that standard deviation because the difference between each data value and the mean, it's not going to be the same if you're looking at the entire population and only a group of items out of that population. So the sample standard population, which I'm going to mark it like this, it's equal to the standard deviation for the population over the square root of n. So in this case, it'll be 1.39 over the square root of 50. Now, if we do that, first let's go ahead and find what is the square root of 50. That will be 1.39 over 7.07 And 1.39 divided by 7.07, it's going to be 0.19. Or let's say 0.20. I'm actually going to round. So this will be 0.20. Okay. So again, the standard deviation for our sample is 0.20. So this is the first thing that we're going to be using, right? Now, when it comes to the probabilities, we know that we need to find our z-scores first. So for our z-score, we're going to have to find or use the formula z equals x value minus the mean over the standard deviation of the sample mean. Now, the x value that they gave us, right, it's 8, so we're going to have 8.00 minus the mean, which is 7.89, over the standard deviation for the sample mean, which is 0.20. Okay. Now, if we subtract $8 minus 7.89, we get 0.11 over 0.20, which is 0.55. Right? So 0.55 is going to be our z-score. That means that on our graph, we are going to go, so again, this is a standard normal distribution. We're going to go to 0.55, let's say it's here. And it says that we want to find the probability that the mean cost exceeds $8. So it's more than $8, so more than 0.55, so we're going to be looking towards the right. Okay. So what we're going to do now is we're going to look at our table from our table E from Appendix A. Now this is a positive value, so that's page 651. And then from the table, when z equals 0.55, the area, and again the area is to the left, right? So 0.55 will give us 0.7088. And that is basically the area to the left. Okay, so all of this is 0.7088. So what we're going to have to do is, again, we're going to have to subtract that from 1 because we know that the entire area is 1, right? So the probability when z equals 0.55, it's 1 minus 0.7088. And when we subtract that, we get 0.2912, and that will be the probability of this sample mean distribution.